Hello, hello, hello. All right, we've got a pretty menacing next section. So pretty much all the stuff that I was talking about for triangle congruency gets a little bit difficult. Moving on to the next thing, which is going to be, well, triangle congruency and proofs. I'm going to repost the video and notes for proofs with this quiz as well, including this one. Those will all be under this, but I mean, it's not as hard as I'm going to make it look, I guess, because you guys only have to fill in like one or two blanks at a time versus doing the whole proof. But let's just go through what I didn't go over last week. So last week we had the four criterion for basically saying this triangle is equal to that triangle. We had, let me get my text up here. So we had SSS, or side, side, side. We had SAS, side, angle, side. We had ASA, angle, side, angle, when the side you know is between two angles you know. And AAS, when you have two angles on the side and the side isn't between the two angles. So there's one more little, like, these two triangles are congruent to each other. There are five. These are the first four, and the last one is HL. HL. So, I mean, obviously, I'm going to be talking about HL right now. Why isn't this working, please? There we go. So we're going to be talking about HL in this format right here. So we've got two triangles. We've got, I don't really have a whole lot of room to write, do I? Give me 1 second. I'm not gonna lie, if you haven't figured it out, I like showing off my desktop backgrounds as I do this, but I gotta cover this up this time to work, unfortunately. All right. So we're gonna talk about HL. So, you know, we've been basically only referencing sides and angles. SSS, side, side, side. SAS, side, angle, side. Angle, side, angle, 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 side. So what does HL stand for? Well, it stands for hypotenuse leg theorem, or property. I don't know how to spell hypotenuse leg. That's what it stands for. All right. So what does that necessarily include? Well, the HL is actually pretty easy provided you follow three specific instructions. So number one, all right. Number one, the two triangles need to be right triangles. It has to be two right triangles. Two, you need SAS in those right triangles. And then three, one of the S's, or sides, has to be the hypotenuse. So of all of the other this triangle is equal to this triangle things that we have done, you know, SSS, SAS, ASA, AAS, of all of them, this one, of course, is the most complicated. That's why I saved it for a little bit later. But yeah, it's this right here. You need two right triangles, you need SAS, and you need one of those S's to be the hypotenuse. If you don't know what the hypotenuse is, I'm going to show you in a second how to find it really easy. So let's just work through this problem right here and figure it out. We're not going to do a proof or anything. We're just going to look at it. When you're doing congruency, the order of the triangles really matters. The order you go in. So for instance, if I started in this triangle right here, this top one, and I go from A to D to B, that means I started at this right angle. I went across this side with one notch and then down the diagonal. So right angle, notch, down, well, sorry, right angle, notch, diagonal, which means I need to start at the right angle, go across the notch, and then the diagonal. This is really important later on when we do congruency statements as this triangle is congruent to this triangle, because you got to put them in the right order. So if you get to select the order most of the time. So I selected A, D, B. So triangle ADB is, normally I would put congruent here, but I don't, my keyboard special functions, like how I typed out that triangle, it doesn't type out the congruency, but congruency is just equals with a little squiggly line on it. It's like super equals. It's, I don't know, they wanted to be special, so they made it special. But we got triangle ADB, so we need to be in the same order on the other triangle. Right angle, side with the notch, diagonal. Right angle, C, side with the notch, B, diagonal, D. So CBD, CBD. So we're trying to prove that these two triangles are congruent. They are equal to each other in every single way. That's what we want. So I will put that, prove that. Well, you can definitively say that this triangle is equal to this triangle if you can prove SSS, SAS, ASA, AAS, or now HL. So let's go through the criterion real quick for HL. Two right triangles. One triangle with a right angle, two triangles with a right angle. So we got that one. Now we need SAS. Well, we don't have that yet. We only know one side and one angle. I mean, the 90 degrees are equal to each other. We know angle A equals angle C. We also know that AD, right? AD, and I want to put them in the same order as I have them in this. Because if you did your congruency statement right, AD, the first and second letter, will be equal to the first and second letter. AD equals CB. CB, perfect. So we know that's true. I mean, it's already marked in the picture, right? So we know this is true. So now we need to find another side. Well, where are we going to find that? I mean, well, we don't need to find another side. We need to find something else that's equal. These angles are hard to work with. You can see that they're split, but not in half. So you have no idea what they are. But if you notice, ADB, CBD, DBBD, they share letters, don't they? Both of these triangles have two of the same letter. And if you look right down in the middle, they have the same side, don't they? ADB, so DB is the exact same side over here in the other triangle as BD. So we can say, like if we had a proof out here, which you will on the quiz in a little bit, but if we had a proof here, draw that out for you. We're trying to prove this. This was, well, I mean, that was given to us, wasn't it? I mean, that was already marked on the picture. And then we know angle A. I said I wasn't going to do a proof, sorry. I'm doing a proof. I don't have the symbol for angle. You'll see on the quiz the symbol for angle, but I don't have it here, which is really unfortunate. But angle A equals angle C because, well, that was also given to us for the most part. So we got a side and an angle. We need one more. We need one more thing. And we know that DB and BD are equal to each other because they're the same line. So we can say that this guy is equal to itself. I put two dashes to signify that they're different from these two. So this is equal to this, but the diagonal on this side are different. But we can put that now. We can say that DB, because that's what is in our first triangle, right? ADB, yeah. is equal to BD, which is in our second triangle. Now that is not given to us. We figured that out. And we figured that out with the reflexive property. Reflexive property is that one I wanted you to put stars on next to like 2 months ago when we did, gosh, it was more than 2 months ago. When we did proofs, which I'll repost those notes, I told you put a star next to reflexive property. And I mean, this is why right here. Anytime two triangles are touching or, you know, crisscross, basically, yeah, I mean, anytime they're touching in any way, there's probably going to be a reflexive property in the proof saying, you know, this is equal to itself. It is the same in both triangles. So, proof's almost done. We're pretty close to finishing up here. We've got, let's go back over to HL. Do we have two right triangles? Well, yeah, we got two right triangles. We need SAS in those right triangles. Well, I have one side, an angle, and another side, right? So I have side, angle, side. I have SAS. All right, cool. All right, and then the last one. One of the sides, one of the S's, has to be the hypotenuse. If you're very unclear as to what a hypotenuse is, let me help you out. Hypotenuse is the longest side of a right triangle. That's normally pretty apparent, but sometimes they're drawn pretty awkwardly. So what you can do is look at the right angle, because the right angle is an arrow that points to the hypotenuse. So the hypotenuse of CBD is this side right here. Where is my little... This is the hypotenuse. This side, DB or BD. If I did the same thing in the other triangle, you would see it's exactly the same. The right angle is an arrow that points to the hypotenuse right here. So anytime you need to find the hypotenuse of a right triangle, you just go down here, follow basically the point of the right angle, the box, straight across to the first line you run into. That's the hypotenuse. And, I mean, I'm going to delete that guy. I'll keep the arrows up. But one of the S's that we know, this guy right here, is the hypotenuse, isn't it? Which means that these two triangles are equal through HL. So I could take this guy, put him down there, and my reasoning would be HL. These two are equal because of hypotenuse leg. So it's just like the first four, SSS, SAS, ASA, AAS, except it has more stipulations. I like HL because you can rule it out pretty quickly. I mean, the very first thing you should do anytime you look at, you know, are these two triangles congruent? Well, if they're not right triangles, lop off HL. You're dealing with SSS, SAS, ASA, AAS. If it's not right triangles, you're done. You don't even have to look at HL anymore. You're done. If you have two right triangles, right, you get past the first step. There's two right triangles, but there are two angles. Like they've got this angle and your right angle marked. Well, it's not HL anymore because it can't be SAS because you don't have two sides. You have two angles. So it's out. So use, I mean, a little bit of deductive reasoning, a little bit of like, I mean, well, frankly, well, I forgot that test strategy. Whatever, rule out answers, rule them out, and the answer becomes much easier and much more apparent. But HL is just, it's these three strict criteria, two right triangles, you need SAS in those right triangles, one of the S's have to be the hypotenuse. If any of those aren't there, it's not HL. So if you get to the third step, if you have two right triangles and you have side angle side, you have two sides and one angle equal, but one of those sides isn't the hypotenuse, well then it's SAS. You already proved that. All right, so I know that's confusing a little bit. I mean, geometry is going to get much harder here in January and moving on, but we'll get through it. I got one more thing to show you for the quiz. Of course, I will never make you do, and you're never asked to do, a proof from scratch. By the way, this symbol right here in front of the T is angle, and this is congruent. I got it all over your test or your quiz for this section, which was a pain, but it's there now. So, all right. So I'm going to put this proof together. I'm going to show you how I do it, but this whole process is to explain one new thing that I'm going to talk about in just a second. Let's get through this. So we've got this situation right here. There is a lot going on here. But the very first thing you should always do in a proof is look at what was given to you and copy it. I mean, literally, that's what I'm going to do. It goes down here in the proof. These are the things that were given to me. I don't know why I just did that. There we go. And since they were given to me, I know them because they were given to me. Also, I just realized that none of the proofs have statement or reason, which means I get to redo the whole thing. Fantastic. I will get to that later. Yeah, it should have, man, I am a fantastic speller. Should have statements and reasons above them. That is really upsetting that I didn't put that on all the other quizzes or all the other ones that I have to do. That's going to just be time. All right, statements, reasons, cool. All right. So we've taken the two givens. There was a given here, put them in the proof, we're done. But those are two sides. That's only two sides. I need to find a third thing. If I find an angle, it's SAS. If I find a side, it's SSS. If I found a right angle, it still wouldn't be HL. Because if I found that R and T were right angles, which I can't, I'm just making this as an example. If I found that they were right angles, then I would have SAS, but the sides, right, aren't the hypotenuse. So it would be SAS, it wouldn't be HL. But that's not the case here. We have no information to work with angles or anything. Frankly, the only thing we have is, well, this middle line. These two triangles share a side, SU, US, right? So it looks like SU is congruent to US. And I know that because, again, the reflexive property. The reason why I wanted you to put a star around that, the reason why it's important, is because it shows up so much. It shows up so much. All right. Well, I have a side, and a side, which means I know that triangle, and then let's make sure we get the order right. I'll do that. Let's go across the one with one notch and then the diagonal. So TSU is congruent. Well, I started in the corner, went across, started in the corner, RSU. Triangle, RSU. Oop, I messed that up. There you go. Cool. So I know that this triangle is congruent to this triangle because I have proven side, side, side. Literally. Side, side, side. But why is there an extra step? Why is there an extra blank? Well, we weren't trying to prove the two triangles congruent. We're over here. We're trying to prove that angle T is equal to angle R. But nothing in this picture and nothing in our givens would ever let us get to any angles because everything's a side. We could never actually talk about these two angles. And that's the new thing that I'm going to teach you right now. There is only one step in a proof that comes after this triangle is equal to this triangle. There's only one step. And it's pretty much, not even pretty much, it's always going to be, if what you were trying to prove wasn't this triangle is equal to that triangle, then whatever you were trying to prove, in this case, this angle equals this angle, is going to be the next statement. And the reason is this really crazy thing called CPCTC. CPCTC. Of course, I'm going to explain that. C, oops, P, C, T, C. All right. So CPCTC stands for corresponding parts of congruent. I'll capitalize the ones I use. Corresponding parts of congruent triangles are congruent. That's what CPCTC is. It will always be the last reason in a proof about triangle congruency. It's always the last reason, and it always, always, always comes right after this triangle equals this triangle because SSS, SAS, ASA, AAS are now HL, those five. The second one of those five is in a proof. Oops. The second this triangle is equal to this triangle. If you ever need to go another step further, it'll always be the reasoning CPCTC. What this states is, if this triangle, TSU, is the same as RSU, then every corresponding part of those triangles are equal. So angle T, the very first letter here, is equal to angle R. Angle S equals angle S, right? And then U equals U. Same with all the sides. TS equals RS, SU equals SU, UT equals UR. They're all the same. They're the same exact triangles in two different places. CPCTC is just, well, any of those parts, like I put here, any of those parts are equal to each other now because we proved that the two triangles are the same. You will never see this reason, CPCTC, anywhere else in a proof, ever. It's always the last reason. And right above it is always one of those three, well, and HL, one of those five, these triangles are congruent to each other, which are, of course, again, SSS, SAS, ASA, AAS, or HL. So I know it's a lot of letters and it's so many acronyms. I mean, I'm going to put the notes at the top of the quiz, of course, but the only two new concepts that I'm talking about are HL and CPCTC. Now, when you look at your quiz, you're going to notice that there are plenty of those examples, even if I'm not asking you specifically to fill in that blank. So, you know, your fifth question here on the quiz is asking you why these two triangles are congruent, which means you need to use SSS, SAS, ASA, AAS, or HL. But CPCTC is there, reflexive property, and then throwbacks to substitution. All that stuff is there because I want you to remember all that stuff because it's important. I think the only other thing, no, I think we're good. That should be good. I guess the only other thing I want to talk about is when two things are butting up against each other like this, you got to have a better specific way to name an angle. We went over this in like the third week of geometry, but I want to make sure you remember it. You see this right here. This symbol means angle. This is angle ACB. So what you need to do is trace these three letters with your finger. Angle ACB, angle, ooh, I think I have a little spotlight. I do. All right, angle A, all right, angle ACB. This angle right here, ACB. You just trace it with your finger and it just, you know, basically shows you where it is. The middle letter is the vertex. It's going to be where the two lines meet right there. And this is the angle. ACD is this one right here. But that's how they differentiate because there's only one letter here. And if you said angle C and angle C, that's really confusing because they are two different angles. So if you ever see the angle symbol and then three letters, trace them with your finger and it'll literally draw the angle. All right. I do believe that's just about everything. I got a lot of notes to post. I also have to redo statements and reasons on all of these. So I got plenty of work to do before I put this video out, which is great. But I do believe I've taken up enough of your time. So if you have questions, of course, message me. We can set up some Zoom tutoring or whatever. But otherwise, have fun, work hard, and enjoy everything. Peace out.